Hello and welcome. In this video, we are going to find properties of moist air. As you know, moist air is a combination of dry air, a mixture of dry air and water vapor. Well, it's given that saturated air, which means the relative humidity, or also known as phi, is 100%. So this is one property we know. Temperature, the dry bulb temperature is given, and the total pressure is given. Notice, moisture being mixture of two gases, two perfect gases, we need three independent properties to find its state. Well, so let's go. It's a straightforward problem. Let's go and launch a test tab, a property finder. So we go to the state, system state, and find the moist air model. MA model is right here. That will launch the test tab. Okay, so what are the information provided to us? The pressure is already by default 101 kPa, so we don't have to do anything there. The volume of the system is given, 10 meter cube. The temperature is given, which is 25 degrees Celsius, and finally the relative humidity must be 100% because the air is saturated. So that finds all these variables, and I want to take a minute to go over a lot of the important variables. Notice that all the pressures are given here. This is our total pressure. It's made up of dry air, PA is dry air, and water vapor. Together, vapor pressure and dry air should produce the total pressure. That's the Dalton's law of partial pressure. Then what is PG? PG is the maximum possible vapor pressure. And because the air is saturated, notice PG and PV are equal. Let's go ahead and find the state with 50% relative humidity. So if the relative humidity is 50%, you will find that the PV will be half of PG. So let's just prove that, everything being equal. Vapor pressure, volume is 10 meter cube, and the temperature is 25 degrees Celsius. And as I said, you will see PG is twice that of PV, or PV is half of PG basically. So anyway, so let's go back to state 1 and find all the answers. So these are our pressures. The temperature is given here, and the TDP is the dew point temperature. Notice it is equal, again, it's saturated, that's why they're equal. But, so notice it's equal, but if we go to, let's say, state 2, you will find dew point temperature is lower than the temperature because relative humidity is 50%, and you have to cool the air down further to make it saturated so that dew appears. Similarly, if you go to let's go back to state 1, you'll notice that the wet bulb temperature is also equal to temperature for a saturated state. And the omega has been found. What is omega? That's the mass of water vapor divided by the mass of dry air, right? So all the masses are given here. Let me show you all the masses. This is the mass of dry air right here. Mass of dry air, this is the total mass, and then this is the mass of vapor, this is the mass of maximum possible mass of water vapor. So these are all masses put next to each other. This is the most important quantity because for air conditioning, for psychrometry, the dry air mass is most important because that doesn't usually change in an air conditioning apparatus. So that becomes the basis. So when you find, say, specific volume, for instance, or enthalpy, the units are always per unit mass of dry air. But if there is 11.46 kg of dry air, you can see that total mass is higher because it carries some water vapor. In this case, the maximum amount of water vapor. So in short, if you know three properties, and generally pressure is always given in air conditioning, usually atmospheric, then you need altogether three properties. So beside the total pressure, you need two more to figure out the thermodynamic state of moist air.